I'd pay extra close attention today because the SAT does love some of the vocab that we're going to go over on these notes. So today we are starting our polynomials unit. We're going to go over some basic vocab surrounding polynomials using this example to help us through it. F of x equals, let's pause there. What does f of x represent? Thank you. Why? And again, I say that because I can guarantee every single person in this room, you will see f of x appear on your SAT 100%. They love f of x. They know that f of x is going to throw off stump, confuse a lot of students. So that's why they like to use it. It's just why. Don't overthink it. Yeah. So our equation, f of x equals 5x cubed plus 9 minus 4x to the 6th minus 8x to the 4th minus x to the 5th plus 10x. First thing we need to do is put that equation in standard form. Standard form is a specific order. It's how we always write our answers, whether you were aware of that it had a proper name or not. That means you put the terms in order from biggest to smallest exponent. Don't forget to start with that f of x or that y equals that's given. We need to identify the highest term so we can figure out our order from there. The highest exponent was negative 4x to the 6th. X to the 6th was the highest exponent. We'll take that entire term, including the sign in front of it. Negative 4x to the 6th, that goes in front. And from there we go in descending order. So we'll look for the 5th next. It's 2 terms over, negative x to the 5th. And then the 4th, that's in front of that one. Negative 8x to the 4th. And then the 3rd power, that's at the front, 5x cubed. It's positive, so we need to put a plus in between those two. Plus 5x cubed. Then we look for a square, and we don't have that, so we'll jump right onto the plain x at the end here. Plus 10x. And our last term, plus 9, has no x attached to it, so it goes at the very end. Any questions that we answer from here on out are going to be answered according to that standard form of the equation. It's a lot easier to work with. Degree, we've seen this before. Reminder, degree is the highest exponent. This is why we want the terms in order. We just look at the very first term. Highest exponent was 6. Leading coefficient, again, this is why we put the terms in order. First off, we often refer to this as the LC. So if you see that, that's leading coefficient. And that's the coefficient of the highest term. Leading as in the front. If this is in standard form, then it's just that first term. Negative 4x to the 6th, that's the highest term. And the coefficient just refers to the number in front of the x. So in this case, negative 4. So our leading coefficient is negative 4. Just write down the number, don't include the x. constant term. This is not a new word. Which part of this equation is the constant? Nate?
My bad.
No, you're correct. Say it again.
Oh, no, I was saying my bad for that shadow.
You were thinking of the what?
No, I said my bad for that shadow. Yeah,
No, that's fine. That's fine. You're correct. What is it?
9.
9. Constant, when written in order, is always at the end. And it's the one term that has no variable. That's what makes it a constant, is the absence of a variable. So a nice definition is just a number. No variable. This last term here, we're going to spend a bit of time explaining what it is and what it means, what it looks like, because it has a lot of parts to it. End behavior. How a graph acts on the left and right sides. And it can act two ways, or I guess it could go in two directions, up or down. That's really all we're going to be looking for. Going through this initial explanation is going to make it seem very complicated, but it's not. So once I have all the details laid out and we can see the big picture, you're going to realize this isn't bad at all. In behavior, there are two factors you have to consider. Whether it has even or odd degree, and then whether it has a positive or negative leading coefficient. Let's start with even versus odd. Even degree, that would be if you had x squared, x to the 4th, x to the 6th, anything like that, anything with an even exponent. Odd degree would be the opposite of that. If we had just x, x cubed, x to the 5th, or any other odd exponents, that would be odd degree. Let's start with the even category. Those are the easier graphs to tell. So if you have a polynomial that's even degree with a positive LC, positive leading coefficient, its graph is going to look like this. Generally speaking. Reminder, this is end behavior, so we're looking at what happens on the left and the right, the very far ends of the graphs where they're going. They're both going up. So we call this up and up. You just describe what the directions are, that's it. So let's look at a couple leading terms that would give a graph like this. Two little examples here. We could have 2x to the 6th, or we could have 3x to the 4th. Both of these are even degree, even exponents, and then we don't care what type of number we have in front, even or odd. We just care that it's positive. This is a positive leading coefficient here. So if this is our leading term, either of those would make a graph that looks kind of like that. Let's compare and look at the negative scenario. The negative graph is the exact opposite of up and up. Both arrows will be pointing down. Down and down. And I'm going to recycle those examples above. To make those two examples fit this category, all we have to do is slap negative signs in front of both of those. Negative 2x to the 6th and negative 3x to the 4th. Now we have a down and down graph. Still even degree, but now the leading coefficients in front are negative numbers, causing the graph to point down in both directions, both sides. So there are patterns that we're going to pick up along the way here. In the even graph, both ends of the graph go the same direction, both up or both down. That is unique to the even degree. So these will go in the same direction if it's even. For odd graphs, we can't have a repeat of this, so we're going to have one of each. Odd degree graphs go opposite directions. Odd graphs, you'll have one of each. One side will be up and one side will be down. For the positive scenario, it'll go down on the left and up on the right. Down and up. Couple examples. We could have 5x to the 7th or 4x cubed. Odd degree, the exponent is odd, but the number in front is positive, positive leading coefficient. We don't care if the number in front is even or odd. Our last category, odd and negative, is going to be the exact opposite of down and up. Up and down. Go flip. For our examples here, once again, we can take the two above and just put negatives on them to make that work. Negative 5x to the 7th, negative 4x cubed, and now we have the odd degree negative LC case. Before we flip over, I do have one more pattern I need to point out to you. So just for a quick recap, you can easily tell the difference between even and odd. Even, both arrows go up or both go down, same direction. Odd graphs, you'll have one of each. One will be up, one will be down. Now to tell the difference between the positive and negatives, let's look at the positive graphs. Just compare the two, the even versus the odd graph. These two graphs have something in common. What is it?
Both on the right side.
Yeah, exactly. On both of them, the right side is up. That's because they're both positive. So that's what positive guarantees. A positive graph, the right side will be up. That's how you'll know just by looking at it that it's a positive graph. The same phenomenon occurs for the negative graphs. The right side specifically is down on both of them. So if you have a negative graph, the right side is down. And we only look at the right side to determine that, not the left side. The left side will have us figure out even or odd, but the right side specifically tells us positive or negative. If you remember the patterns I just showed you, same direction, opposite direction for even versus odd, right side up for positive, right side down for negative. If you remember those two patterns, you will remember this table without having to straight up memorize these pictures necessarily. Questions on the end behavior charts? We'll get some more practice with this. Backside. We're going to do a little exercise going through the terms here with a new polynomial and looking at a couple new vocab terms. First thing we're going to do is put this polynomial in standard form. F of x equals 2x plus 4x to the 5th minus 1 plus 8x to the 4th minus 3x cubed. While I read through that, I'm looking for the highest term. The highest exponent I found was x to the 5th, so that will go in the front. We have f of x equals 4x to the 5th. Next term is 8x to the 4th plus 8x to the 4th. Next term is our cube minus 3x cubed. Once again, this problem doesn't have a square term, so we'll skip on over to the plain x. 2x, don't forget to connect it with a plus 2x. And minus 1 is our last term that goes at the end. What's the degree?
5.
Correct. 5. Degree is the highest exponent. This is why we put the things in order. It makes it very easy to identify these terms. Degree is 5. What's the LC? Good. LC, leading coefficient, it's the first number. Constant?
-1.
Good. -1, it's the number at the end. Again, if you put it in order. Number at the end, no x on it, just the number. Couple new things here, the number of possible zeros. This is the same as the degree. So the degree was 5, so there are 5 possible zeros. Don't get too hung up on the word possible. This is just an educated guess based on the polynomial. That means we could have up to 5 zeros, but not anything more than that. We can also have less than 5 zeros. So that 5 isn't a guarantee, it's just a maximum prediction. Number of possible terms. This is the degree minus 1. Or possible zeros minus 1, however you want to see that. Our degree was 5, so there are 4 possible terms. Again, not a guarantee, but that's how many there could be. There's one more vocab term I need to add here that I forgot about, and that's in behavior. So how we find that? We take that leading term that we placed and when we went in order, and it's 4x to the 5th. We have to figure out even or odd and positive or negative. So the even or odd, that comes from the degree, the exponent. 5 is odd. And then the LC, the leading coefficient, 4, is positive. We don't care that it's an even number. We just look at whether it's positive or negative. So we have odd and positive. Now let me talk you through this without looking at the chart on the front side, how our graph is going to look. Odd means opposite directions. We'll have an up and a down, but which is which? That's the question. Positive means the right side arrow is up, and since the other arrow must be the opposite direction, we know that the left side goes down. This is how you talk yourself through to the right shape without just memorizing it. Just use the two patterns I showed you. So if we go left to right, our end behavior is down and up. All right, using all the information we just found, we're going to create a very, very rough sketch of the graph of this polynomial. It will not be accurate, it'll just be an idea of what this graph might look like based on the information we have in front of us. And if you don't like this part, this is the only time we're going to do this in this class. We won't do it again on notes, quiz, test, homework, any of it. So just bear with me. First thing I'm going to graph is the end behavior, the arrows where they're going. We have the left side ends down, so the start of the graph is down, and then the graph ends on the right side going up. And then we have to figure out what the curve's going to look like from there. A couple more details that I haven't really talked about yet. Our constant -1 also is a special part on the graph. This is also the y-intercept. The constant at the end is the y-intercept. So, on our plane here, we'll call this -1. I'll go ahead and put a point there. One more item, the zeros. Again, it's been a moment, so I'm sure you've forgotten what a zero is on the graph. Zeros are your x-intercepts. Again, this is where we're doing the educated guessing. It didn't say that there were 5 zeros, it said there are up to 5 zeros. So I'm just going to assume there are 5. It didn't tell me where those were at, so I'm just going to place them on my graph. For your curve to turn out correct, you need 2 on the left and 1 on the right, just a heads up. Two on the left, 3 on the right. I didn't say that correctly earlier. Just get 5 on there. I've mapped out everything I can. From here, we're going to fill in the gaps from there. So starting at our arrow here, we're going to go up and hit our first point. I'm going to go up a bit more. In order to hit the point next to it, I have to turn around at some point. So let's turn this graph around and hit the next 0. We'll go down a ways. Same issue. I'm going to have to turn around eventually. So let's turn around. Hit the y-intercept, and let's go ahead and hit this next 0. That's the next place it's going to hit that x-axis. Up a bit, turn around to hit the next 0. Down a bit, turn around to hit the last 0, and then connect to the up arrow. So there is a general sketch. There are many things we can do to improve it, but with limited information, this is the best we can do without a calculator. All right. And by the way, turns, we turned 1, 2, 3, 4 times every time we changed direction. That's where the number of 4 possible turns comes from. That's what that looks like on the graph. Now that you've drawn these items yourself, it's going to be easier to identify them on the actual graph. We have 5 questions per graph. These will go by very quickly, A through E. A, describe the end behavior. We just want the directions, nothing fancy. Left arrow is going up, right arrow is going down. So up and down. B, determine if it represents an even or odd degree polynomial. Up and down, even or odd. Odd. Good. This is an odd function. We know that because these are opposite directions. This part's just for notes. C, determine if the leading coefficient is positive or negative. Is this a positive or negative graph?
Negative.
This is negative. Good. Negative, you look at the right side and see where it's going. If it's going down, it's negative. Up, it's positive. Right side is down. D and E, you just look for these items on the graph and count. D, state the number of real zeros. Real means they're actually there. We actually know that these are actual zeros. So you go through and count how many places it hits on the x-axis. 1, 2, 3, 4, 5. It hits 5 times. Again, each one of these points is a 0. There are 5 zeros. And then finally, E, state the number of turns. You just count how many times the graph changes directions. So if we start up and follow the graph, we turn here at the bottom, go up a bit, we make a second turn here, down a bit, third turn here, up a bit, fourth turn here, and that was the last turn. So each one of those circles represents a turn, and there were 4 turns total. We'll quickly do that one more time for our last graph here. First thing we look at is which direction both arrows are going. That's the end behavior. In this case, the left and the right are pointing down. So this graph is down and down. Even or odd?
Even.
Even, correct. Even, same direction. It's an even function. Or even degree, I should say. Positive or negative?
Negative.
Negative when they're both going down. That one's kind of obvious. But specifically, just like the first problem, specifically the right side is going down. That's what makes it negative. So this is an even and negative graph. D, the number of zeros?
2.
Yep. Hits only twice this time, so there are 2 zeros. Again, that's how many real zeros, how many places it actually crosses. And finally, the number of turns. This one's a little wonky. This graph actually changes direction 3 times, so there are 3 turns. Very good. That's all for today.